Hey there, tech lovers. I'm Harshit Kishore, your go-to React Native developer here at Quokka Labs, where we are all about pushing the boundaries of technology. Today, we are diving into React Native, the incredible framework developed by Facebook that's transforming mobile app development. We will break down how it works, explore its architecture, and uncover why it's a game changer for building apps faster and more efficient. So, whether you are seasoned developer or just curious about how your favorite apps are made, stick around. This is going to be a fun and insightful journey into the world of React Native.
So first, what is React Native? So what exactly is React Native? Simply put, React Native is a tool that allows you to create mobile apps for both iOS and Android using just one code base. This means you can write your app once and it will work on both platforms. Pretty cool, right? React Native uses JavaScript, the same language you use for building website, along with React, a popular library for building user interface. This combination helps you create mobile apps that look and feel native. Means they perform just like app built specifically for iOS and Android. So how it works? How React Native works. So let's know the mystery behind how React Native works. I promise to keep it simple and easy to follow. So let's jump right now. So imagine your React Native app as two separate pieces, the native code and the JavaScript code. The two pieces speak different language and can't communicate directly. So let's understand the process. The entire process happen in 5 steps. First step is writing code. So first you write your app using JavaScript and React. It's like creating a website but for mobile apps. Second step is compilation and bundling with Metro. So next we need to transform this React Native code into something our phone can understand. This is where the React Native CLI comes in. So the CLI uses a tool called Metro to gather all JavaScript code and assets into one neat package. Metro is like a super organizer for your code. So Metro takes all your JavaScript files and bundle them into one single file. Think of it as packing everything into one compact suitcase. So the third step is native compilation. So now the React Native CLI compiles this bundle file into native code. For iOS, it uses Xcode, and for Android, it uses Android Studio. These are the tools that speak the phone's language and translate your JavaScript bundle into native instructions. The fourth step is the bridge. During this process, the native code and JavaScript code are connected using the React Native bridge. The bridge is the communication channel that lets them talk and work together smoothly, sharing data back and forth. The next step is deployment. So finally, once everything is compiled and linked, your app is ready to be deployed to a device or emulator for testing, and your app is up and running. So now let's dive with React Native architecture. When we talk about architecture within the React Native ecosystem, there exist two distinct paradigms for implementing native modules: the old native module system and the new native module system. So old native module system, also known as bridge-based native module system or the legacy native module system. This system basically uses JSON data serialization to communicate between JavaScript and native code. Think of it as writing letters back and forth. It works, but it can be slow because you have to package and unpackage all that data. This method is effective but can introduce performance bottlenecks due to the overhead of serializing and deserializing data. The second one is the new architecture. So new native module system, also known as turbo module system, which uses something called JSI. JSI is written in C++. So JSI allows direct communication between JavaScript and native code by passing the need of data serialization. It's like having a direct phone line instead of sending letters, making everything faster and more efficient. This result in improved performance and efficiency, making it a more attractive option for developers who want optimized solution. So now we will go in depth with these architecture. Let's start with bridge-based native module system first. So when you hit run on your React Native app, the magic unfolds across three distinct threads, each playing a crucial role in delivering your app's functionality and user interface. The first one is JavaScript thread, second one is a native thread, and third one is shadow thread. We will explore the three main threads that make everything happen. So first we will explore JavaScript thread. It is also the heart of the app. This is where all your app's logic and behavior reside. The JavaScript thread execute your app's JavaScript bundle, handling everything from API calls to state management. It runs on JavaScript engine, usually hums or JavaScript core, depends on your setup. Think of it as the brain of your app, making decision and controlling what happen next. Second one is native or UI thread, also known as main thread. So you can also call it a powerhouse. This thread is responsible for rendering your app's user interface. It's like the stage where all the action happens, ensuring everything you see on the screen looks and feels right. It handles all user interaction, UI rendering, and gesture events, making sure your app respond smoothly to every tap, swipe, or scroll. This thread runs natively on the device, just like in any other native application, providing a seamless user experience. So the third thread is a shadow thread. The shadow thread operates behind the scene, performing a critical task, calculating the layout of UI elements before they render on screen. Think of it as the backstage crew preparing the set of grand performance, making sure every element is in its rightful place for the audience to see. By handling layout calculation separately, it ensures that the main thread can focus on rendering and user interaction without any lag. So together these threads make sure your React Native app runs smoothly and efficiently, providing a great user interface. So now let's understand how communication happens between JavaScript and native code in React Native through something called the bridge module. In React Native, the bridge module is like a super important messenger. It connects the JavaScript thread and the native thread, allowing them to talk to each other and share data. But there is a bit of process involved. Imagine your JavaScript thread need to interact with the camera module. So you can see in this picture how it communicate with camera. So first the JavaScript thread create a message that says what it wants to do, like taking a photo or opening a camera. Before sending this message, it gets serialized into JSON format. This is like translating the message into a common language that both sides understand. So the serialized message now travel across the bridge. Think of a bridge is a tunnel that connects the JavaScript and native world. So the message is optimized and forwarded by the bridge to the native thread. On the other side, the native thread receives that message and decode it from JSON format back into something the native code can understand. It then execute the required native code like turning on the camera or taking the photo. So what benefits of old architecture? So first one is a non-blocking communication. Since the bridge uses asynchronous communication, it allows for non-blocking interaction between JavaScript and native code. This means that the JavaScript thread can continue executing while waiting for responses from the native side, keeping the app responsive. So second one is smooth view management. This non-blocking nature helps maintain smooth view management on screen at 60 fps. It ensures that the user interface remains fluid and responsive even when handling multiple tasks or interaction simultaneously. So there are some challenges with old architecture. We will explore them. The first one is serialization overhead, and second one is asynchronous update. So when data need to travel between JavaScript and native code, it has to be serialized into JSON format before crossing the bridge. On the other side, it's then deserialized back into a usable format. So this whole serialization and deserialization process takes time. As your application scales and exchange more data, this delay can start affecting performance. It's like having to stop and process every single message at the toll booth. It slows things down. Let's understand with the example. So a user is typing their credit card number into an input box, and we want to format the number with a space after every four digits. As the user types, JavaScript format the input, but because of asynchronous communication, there is a delay in updating the UI. The user might see unformatted text like 42578 before it updates to space between these digits after four digits. This delay can make the app feel laggy. With many updates happening at once, these delay can become more noticeable and similar to a bridge that's getting congested with the too much traffic. So to tackle these problems, the React Native team found a better and more efficient way to combine JavaScript with native code and introduce the JSI, known as JavaScript interface, into their new architecture. So the new architecture of React Native introduced in version 0.68. This new architecture aims to improve performance, memory management, and reduce time to interaction for your application. Let's dive into the key component that make it all possible. So the new architecture brings several advancements to React Native, making it more efficient and powerful. So here are the four components you need to know about. The first one is JSI, which replaces bridge with more efficient communication. Second one is Fabric. It improves rendering performance and flexibility. The third one is Turbo modules, which enhance the performance of native module. The fourth one is Codegen. So it ensures type safety between JavaScript and native code. So, what is JSI? So let's first understand JSI. One of the most exciting feature of React Native new architecture, the JavaScript interface or JSI. This is a game changer for how JavaScript interact with native code, and it packed with some impressive compatibilities. So what is JSI? JSI or JavaScript interface is a unified, lightweight layer designed to work with any JavaScript engine. It's written in C++, which means it's not just limited to Android or iOS, but can target a wide range of systems like smart TVs and watches. The big win with JSI is that it allows direct communication to native APIs. This means JavaScript can now interact with native modules more efficiently than ever before. So, how does JSI work? Unlike the old bridge module, JSI allows JavaScript code to hold a reference to native modules. This reference lets JavaScript call methods or the on the native side directly. One of the standout feature of JSI is its support for synchronous communication. This means when React Native want to update the UI, it send message directly to native side in real time. This native layer then respond immediately, allowing for smoother and more responsive updates. So next question is why JSI is important. So by enabling direct method calls and synchronous communication, JSI reduces latency and makes interaction between JavaScript and native code faster and more efficient. The use of C++ means JSI is not restricted to just mobile platforms. It opens the door for React Native to be used in wider range of application and devices. So, second component is fabric. So, what is fabric? According to the official React Native documentation, Fabric is React Native's new rendering system, a conceptual evolution of the legacy render system. So it's designed to enhance how user interaction and other tasks are handled within your app. So Fabric allows your user interaction like scrolling and gestures to be executed synchronously on the main or native thread. This means these critical interaction get immediate attention, resulting in a smoother and more responsive user experience. Meanwhile, tasks that are not time sensitive like API requests are handled asynchronously. This separation helps keep the UI responsive and free from unnecessary delays. So the new shadow tree, one of the key innovation with Fabric is the new shadow tree. Unlike the old architecture where React Native maintained two separate hierarchies or DOM nodes, the shadow tree in Fabric is immutable and shared between both the JavaScript and UI threads. This shared shadow tree allows for direct interaction between the JS and UI threads, reducing the need for duplicate data and cutting down on memory consumption. This means your app will be more efficient and useless memory overall. So, by sharing the shadow tree, Fabric helps to lower memory usage. You no longer need to maintain two separate hierarchies, which not only saves memory but also simplified the rendering process. So, third component is turbo modules. Turbo module are an upgrade over the old native module system. They provide a more efficient way to manage native code and improve performance by allowing JavaScript to load modules on demand. In the old architecture, all native modules like Bluetooth, geolocation, file storage need to be initialized before the app even opens. This means that even if a user does not need a particular module immediately, it still gets initialized at startup. This pre-initialization can slow down the app's startup time and consume unnecessary resources, especially if many modules are involved. So with the turbo module, JavaScript can hold references to these modules but only loads them when they are usually needed. This on-demand approach helps streamline the initialization process. By loading modules only when required, turbo modules significantly reduce the time it takes for the app to start up. This leads to a faster and more responsive application. So imagine your app has a camera module that's only needed on the fourth screen. With turbo modules, you don't need to load the camera module at startup. Instead, it can be loaded dynamically when the user navigates to the fourth screen. This approach improves time to interaction, means user can start interacting with your app faster without waiting for unnecessary modules to load. So fourth component is Codegen. Codegen is a tool designed to create interface between JavaScript or TypeScript and C++, which are two very different languages. JavaScript and TypeScript are dynamically typed, while C++ is strongly typed. This difference necessitates a way to facilitate communication between them. So, how does Codegen works? Codegen helps generate the necessary interface that enable TypeScript to interact with the C++ code. These interface define how data and methods are exchanged between the two worlds. Instead of generating native code at runtime, Codegen produce it at build time. This pre-compilation approach helps improve performance and reduce the need of dynamic code generation during app execution. So why is Codegen important? By creating strong interfaces, Codegen ensures that interaction between TypeScript and C++ are consistent and type safe. This reduces the chance of errors and improves reliability. Generating native code at build time rather than runtime helps in optimizing the performance of your app. It ensures that the code is ready to go when your apps run, leading to smoother execution. Imagine your app needs to use a native library written in C++. Codegen will create the necessary bindings and interfaces so that your JavaScript or TypeScript code can call functions and access data from that C++ library seamlessly. So, why new architecture? The Meta team recognized the limitation and bottlenecks of the bridge architecture. So they started working on eliminating these issues. Here are the benefit they introduce with the new architecture. One of the main improvement is synchronous execution. This means that data can be processed in real time without the delay caused by asynchronous communication, making interaction much smoother or more responsive. By eliminating the need of data serialization and deserialization, we have gotten rid of the overhead that slow down performance. This streamlines the communication process and speeds things up significantly. With the new architecture, the startup time of apps is much quicker since we are only loading the modules we need when we need them. We can get our apps up and running faster than ever before. Improved memory management means our apps use resources more efficiently, reducing the chances of memory leaks and other issues that can cause slowdownness or crashes. So that's it for React Native and their architecture. So thanks for watching. If you enjoyed this breakdown, give it a thumbs up and subscribe for more tech updates. If you want to create a custom mobile app with React Native, connect with Quokka Labs. Happy coding.